Welcome to the video lecture for page 2 of PSA. 4 little topics to remind you of to help you with the problems on page 2. The first one is percentage discounts. There's a problem here that talks about what happens when you're given a percentage discount at a store. A couple ways to think about this. Remember the 20%, remember per means per cent, as in 100 cents in a dollar, as in centurion. So you can think of it as 20%. So one thing you can do is do the fraction 20 divided by 100 and multiply that by whatever the price happens to be. We'll keep it simple. Let's say it was a $200 item that we're going to get a 20% discount. So 20% of 200, we multiply this out. Obviously, the 200 divided by the 100 would be a 2. 2 times 20 would be 40. So that would give us the amount of the discount on the particular item. $40 discount, 20% of 200. Again, you can, depending on the question, if the question is, what is the final price, you can always do the 1 minus the discount trick. In other words, if you do 1 minus the 20%, or if we want to do it in decimal form, 0.20, that's going to give you 0.8, or the same thing as 80%, which obviously in this case is the same thing as 8/10. But if you multiply this by the price, so if we do 8/10 or 81/100 or 0.8 times the $200 price, 200 divided by 10 should be 20. 20 times 8 should give us 160. And obviously that's the price that you would pay after the discount is taken. So just a quick little reminder on percentage discounts. The next topic we want to talk about is combining like terms. Again, this should be familiar, but like terms, particularly a polynomial, are in blue, in this case the 4x squared and the 3x squared. The like terms are with the x terms when they have the same exponent. Remember, we cannot combine, little note down here, 2x squared plus 3x. You cannot combine those. Those are not like terms. That's as simplified as you can get that, unless you want to consider, we can always factor the x out, of course. But you cannot combine 2x squared and 3x into one term. Also up here we have x terms, so the things in red, those are like terms. And finally the numbers are like terms as well. So when I combine these, I'll get 4x squared plus 3x squared. Simply 7x squared. So you can think of those, they're like apples. X squared could represent apple, x could represent orange. I can't combine apples and oranges, but I can combine apples and apples. 4 apples plus 3 apples, 7 apples. 4x squareds plus 3x squareds, 7x squareds. Minus 2 oranges plus 5 oranges. In other words, take 2 oranges away from 5 oranges, and I will get plus 3 oranges, aka x's. And obviously the numbers are pretty simple. 4 minus 2 is 2. So that's just a quick example of combining like terms. There's also a nice little problem on here that asks you to compare 5 different numbers. Some of them are given as a fraction and some of them are given as a decimal. You might be able to just look at them and know which is bigger, but if you have trouble with this or if it's a little trickier, you can always translate from decimals into fractions or from fractions into decimals. Let's talk about the decimals. Again, an easy way to do it is remember 0.25 stands for 25 hundredths. This is the tenths column, this is the hundredths column. In the same way that if you look on the left side of the decimal point, this is the ones column, this would be the tens column, the hundreds column, the thousands column. So in the same way, this stands for 2 tenths plus 5 hundredths, or you can think of it as 25 hundredths written as a fraction would be 25 over 100, 25 hundredths. So if you wanted to see whether or not 0.25 was equal to 1/4, now you've got 0.25 as a fraction form, but clearly you could simplify this because 100 is also 25 times 4. And since 25 divided by 25 is 1, we can just kind of take that away. Don't forget you still have a 1 up here. So clearly 0.25 does equal 1/4. This is obviously a pretty simple example. The one on the problems that would be a little more challenging. You could also, remember, turn fractions into decimals. It may have been a while since you've done this. But 1/4, remember, that's simply division. Earlier you may have written it like this, 4 into 1. Well, obviously 4 doesn't go into 1, so remember what you would need to do is put a little decimal point and a 0. 4 goes into 10, goes into it twice. 2 times 4 is 8. Do the subtraction, we get 2. So I've still got something left over, what sometimes we call a remainder. But if I don't want a remainder, that simply means I need to put another 0 here, bring the 0 down, see if 4 goes into 20, and of course 4 does go into 20 evenly. It goes in 5 times. Don't forget the decimal has to stay here. So clearly 4 goes into 1.25 times. 1 divided by 4, also 0.25, which again I'm sure you know already. We're just using this as a nice example for how you can translate from decimals into fractions or fractions into decimals. Again, they're just two different mathematical ways to describe the same type idea. 0.25 equivalent to 1/4. But this will come in handy in one of the problems you have on page 2. And finally, just a quick little reminder, you're probably familiar with the fact that the area of a circle, there's a formula. Later in this class, we will actually prove how that formula comes about. Remember, the area is simply pi, the irrational number pi, times the radius squared, or simply pi r squared, where the radius is the length from the center of the circle to the edge of the circle, and obviously the radius is the same regardless of where I draw it to on the circle, which is actually the definition of a circle. So area is pi r squared. Quick example, if the radius was 4, the area is simply going to be pi times 4 squared, or pi times 16. Good luck on page 2. I will see you in class tomorrow.